Okay, so now we're going to look at radical expressions where the radicand is a variable. Okay, and there's some things that we have to be careful with, but we'll talk about that. So you have the square root of b to the fifth. So you could write that as, b times b times b times b times b. And since it's square root, you're looking for pairs. And so you'd have b times b on the outside, and then a b left over on the inside. So we would write the final answer as b squared times the square root of b. And that would be fine. That would be the answer. Now, we'll do the next problem, and then we'll come back to A. All right, so now you look at the next one. It says the fourth root of y to the sixth. So it's the fourth root of y. How many is that? Okay, y. So 4 of them are making a group that gets out. So you put y, and then you have left y squared on the inside. Okay? But here's the thing. You don't know if y is positive or if it's negative. And so we have to put absolute value around that y that came out. Okay? Because we need it to be positive. Now, if you look at the original problem, y to the sixth was going to be positive no matter what, and you were going to be able to take the fourth root of it. But you have to make sure that on the outside, if it turns out that you have an odd exponent on the outside with your variable, then you need to put the absolute value around it. Okay? All right, and then there's one more thing on that. And I go over these rules in another video, but this will help. So now if we go back up here, why don't we have to put the absolute value on that b squared? Because the square is even. And so we don't need absolute value. So it's something we have to watch for when we have variables in the expression, if it's going to have the absolute value or if it's not going to have the absolute value. Okay, so we'll talk about it more with other examples. Here comes another one. So you have the cubed root of z to the fifth. What we're really doing, because you don't want to write out z's all the time or whatever the variable is, we're saying how many times does 3 go into 5? And it goes in 1 time, and then the remainder is 2. So you have that one group of 3, so that gets you a z on the outside, and then it's the cubed root of z squared. Now, you're probably saying, oh, she didn't put the absolute value around the z. Here's the thing. If it's an odd root, you don't have to worry about absolute value. That we learned about previously, but we have to remember that now. So 2 things. If you have an odd root, you don't worry about absolute value. And that's because you can take the odd root of a negative number, so that doesn't matter. So that's one thing you look at. You see if the root is odd or even. If the root, and by that I mean the index, okay? So I guess we can say index. So if you have an odd index, don't worry about absolute value. If you have an even index, then the variable that comes out if it has an odd exponent, then you need absolute value. If it's an even exponent, then you don't need the absolute value, because an even exponent is going to make it positive no matter what. Okay, so this doesn't need the absolute value because it's a cubed root. The index is an odd number. Okay, so we'll keep going. We got a couple more here. So we have this time a number and a variable. Okay, so 32, you might think, okay, 32 is 16 times 2. And then you have y. You could say y to the fourth times y. You could do it this way. And then you could say, all right, how many times does 2 go into 4? Because it goes in, because you've got a square root. So we're going to say the square root of 16 is 4. And then we're going to have y squared on the outside. I don't need absolute value because it's y squared. And then I have the square root of 2y. So that one's done. All right. So now we'll look at this one. We've got 54p to the 10th. It's a cubed root, so you don't have to worry about absolute value. All right, so it makes it a little easier. Cubed root. So you want to think, okay, what's a cubed root that goes into 54? Well, 27 does. 27 times 2 is 54. And then you could think of this as p to the 9th times p, because I'm looking for an exponent that's divisible by 3. Or you don't have to write that out. You could just say, well, 3 goes into 10 3 times, and do it that way. All right, so the cubed root of 27 is 3. And then p to the 9th is going to come out as a p cubed, because 3 goes into 9 3 times. I don't need absolute value. We already said that. And then make sure you put the index here. So cubed root of 2p. Oops, 2p. Don't forget that index, because that makes a difference in the answer. I'm picky about that. All right, one more. So we need a 4th root. Okay, so even root, so I got to worry about absolute value. And then I have 64. 64 is 16 times 4. And 16 is a 4th power. So I don't know if I gave you perfect 4th powers, but 1 to the 4th is 1. 2 to the 4th is 16. 3 to the 4th is 81. 4 to the 4th is, I think, 256. And then 5 to the 4th is 625. And that's all I know. That's all I know. Then I have to use a calculator. All right, and then we have q. You could say q to the 8th times q squared. Okay, so remember the rule for exponents. If you have a to the, if you have a to the m times a to the n, that equals a to the m plus n. So my 8 and 2 add up to 10, and that's why I can write it that way. All right, so the 4th root of 16 is 2. That's coming out. And then I'm going to have q squared. So I'm going to ask, do I need absolute value? No, because it's squared. All right. And then I'm going to have the 4th root. I'm going to have a 4 inside, and I'm going to have a q squared. And so that's going to be it. And that's what we've got. All right.